Hey everyone, and welcome to our lecture video on modules. In this lecture, we're going to talk over what modules are all about and why we would want to use them. We'll look at some simple examples of using modules, and then at the very end, I want to go over an example where we'll write a program that uses a couple of modules in Python. All right, so let's go ahead and get started. So a module is simply another file that contains Python code, and it's one that we can import and use in our script or our modules or even in the interactive interpreter. So we've seen some of this throughout our exploration of Python, such as the math module. When we import that, the code for the math module does exist somewhere, and those functions exist as well. So what we have to do is we have to import that code in order to use it. And we've seen examples of that just using the keyword import at the top of our script, followed by the module name. So here's a good example, I think, that illustrates why we would want to use modules. Here off to the left, so ignoring these three boxes on the right, just looking at these two, you see that script 1 has define, FCT, and SQ, and so has script 2, and both of them are using those functions. So what we can do is we can try not to repeat ourselves, so sort of following the dry principle of do not repeat yourself, and we can extract what's common between these two scripts and put it in its own script file. Such as, what if we created one called funcs.py that contained our FCT and our SQ functions, and then in script 1 we simply imported that script. So when we import a script, we just call it by the name that we named the file, excluding the .py extension. And then within our file, we can use the functions that exist in that module by referring to what we imported it as. So funcs dot will give us access to these functions within the funcs file. So it simplifies our code a little bit, and it also aids in code reusability in that now we have this functions file that we can use in many other programs. Alright, so how are we going to do this? Well, it's good practice to place all of our import statements at the very top of the script. So similar to what we saw over here, at the very top, not within any sort of nested body or anything like that, we'll put our imports up here. And that helps other programmers when they pick up your script and they try to use it. They know all of the dependencies or what modules are required in order to make your script work. So that's what a dependency is. If we need funcs in order to run script 1, then script 1 depends on funcs.py to be there. And if it's not there, we're going to get an error when we try to import it. So when we do an import, how is it evaluated? Where does that file come from? Well, the first thing that Python does is it checks to see if that module has already been imported. And if it has, then it just continues on. If it hasn't, then a new module object is created and it's inserted into a dictionary called sys.modules. From there, the code in the module is executed and it's all placed in the new module's object's namespace. So we've seen how that code gets executed previously when we were looking at the if name equals main stuff, and basically when we do an import, all that code is going to be executed. So we like to put things in functions and use the if name equals main to make sure that whatever logic was in there doesn't execute when it's being imported. So what this is trying to show is the process that Python goes through as it's evaluating source code. And I think it'd actually be better to look at the demonstration here in the Zybook. So we have this source code over here on our left, and it's going to import HTTP server as well as import web page. And what you'll notice here is that the HTTP server also imports web page. So let's take a look at what happens here. The first thing that's going to happen is it's going to check sys.modules and see if that HTTP server is already there. Since it isn't, then it creates a new object, and then it goes and starts reading through this HTTP server.py file. So the code here is executed. We're importing web page now. It saw that web page did not exist in sys.modules, so a new object's been created there, and now it's going to go ahead and read through webpage.py. So this all gets executed. These functions that are defined in web page get brought into memory, and then at the very end, now we have a reference to web page over here in HTTP server. So this code continues executing. We have some variables that get placed into memory, like address and whatever functions get defined down here. And then next, you'll see that we're now continuing looking at this script file, and we're going to import web page. But Python realizes that it's already in sys.modules and it's already been brought into memory, so it doesn't need to do that again, and it skips over it. Alright, so when we want to use a module, we just reference that namespace. So whenever we import something, like import funcs, we call that a namespace, and then we can reference things that belong to that namespace by referring to the namespace and using the dot operator to access the functions inside of it. So here's just another example. We have myfuncs.py. It contains this factorial function, and here in this script file, we're importing myfuncs, and then we're using it by saying myfuncs dot factorial to access this function and be able to use it. So how does Python find these modules when we're ready to import them? Well, it has a systematic way that it goes through searching, and it starts off by looking to see if the module that you're trying to import is a built-in module, one that sort of just comes with Python. Some examples of that and some that we've used are sys, time, math, the random module. All of those are built in, and we can always assume that they're there. But as you've seen with some of these previous examples, we can write our own modules, or perhaps we could be using someone else's module. So there are other places that Python needs to look if it's not one of these built-in ones. And if it's not, what it ends up searching through is this sys.path variable. So sys.path starts with a directory of the script. So the directory that this script is located in, it'll look in there and see, is there a file that matches what you're trying to import? If not, then we can set specific environment variables, which are variables that are available to applications when we run them. We set them at the operating system level, and it'll search through all of those directories that we specify, and then finally it'll end up in the Python installation directory, just looking to see if there's any modules that were placed in there. So I think I have an example of this. Yeah. So this is on my Mac in the shell. So Z shell or bash would be pretty much the same, and this should be the same in Linux. There's a slightly different way that we set environment variables in Windows, and I have a video that goes over that that we'll talk about here towards the end of the lecture. But when I export something, this something, Python path, is my environment variable, and I'm saying that it should equal this /temp Python modules /temp Python modules 2. So these are directory paths, or paths to a directory separated by a colon. And what it's essentially saying is, hey, look in this directory for modules, and then if you don't find any there, look in this directory for modules. So the next thing I did was I opened up Python, and I just wanted to show you what the sys.path looks like. So to do that, we first need to import sys because we don't already have that imported in our script. From there, I can reference its namespace to access its path variable, and that path variable is just a list of paths to search through. So you can see all I'm doing here on each iteration is just printing out the path. The first one is blank, so that's going to search the directory that we're in. Next, we can see those two directory paths that I specified in my Python path environment variable. We have temp Python modules, and temp Python modules 2 was the other path that I specified. Next, it goes and searches in the installation directory. So there's a few of them here associated with my installation. Ultimately, it ends up in this site packages directory. If the module that we're trying to load is not found in any of these directories, then we'll get an error saying that the module couldn't be loaded. Okay, to sort of expand on this a little bit, we don't have to import everything from a script. We could just import little bits and pieces. For instance, let's say that we only wanted to use a certain function out of a module, and we didn't really care to import all of the other functions. Then we could use the from statement. So the from statement allows us to say, from this module, import just these things. And these things we can specify pretty much as a list, just separating the different functions or variables that we wanted to bring in with a comma. So let's look at an example of that. So here we have this file mymod.py, and this is our module. And within it, we have a few things defined. We have x defined as 55, and we've also defined a calc function that takes one parameter, and we can assume that the body is here. In our scripts, if we were to import mymod, then that's going to bring in to our global namespace, obviously mymod, so we'll be able to reference it. And within mymod's namespace, we're going to have x and calc because those were the things defined within mymod.py. If we wanted to, we could get really selective and we could say just bring in calc. That's the only thing that I want to use. So that's what this script below is trying to show you is from mymod. So from this module, import this calc. Okay? And look at what the global namespace looks like. It's a little bit different. Instead of bringing in the mymod namespace here as a part of it, it just brings in calc, and we can reference calc as if it was defined in our script already. Okay, so another thing to notice is we don't have to preface it with mymod.calc like we did up here, because down here we've actually brought calc into our global namespace. Okay, so this is pretty much a refresher here. We want to make sure that when we're writing scripts that we're using the if name equals main, because if the name does not equal main, then it's going to equal the script file's name that's being imported. So that's also one way you could tell if your script is being imported, but for the most part we use this to make sure that our modules don't run code when they're being imported by checking to see if the name equals main. Okay, so that's just another example of that. I'll let you check that out as you read through the book. Lastly, I just want to talk about packages. So packages are groups of modules. It's essentially just a directory that when we import that directory, it gives us access to all of the modules that are stored within it. So to make a package, there's really only one thing or two things that we have to do. We have to create a directory and give it the name of the package, and then we have to create this underscore underscore init underscore underscore dot py file. Usually it's just empty. There are some use cases where we'd want to put some things in there to sort of initialize the package and create some variables or something like that. But for the most part, we can just leave this empty, and then it gives us access to every module file that we have within that directory. So looking over here, you can see how we can use some of this. So let's say that we have import sound, and sound is a module that, or I'm sorry, sound is a package that has these three modules within it, or three files within its directory. I can access these modules by using the dot operator. So we have our package. We just have to reference our package name because that's what we imported. We use the dot operator to access the modules within that package. And then we can use the dot operator again to access the functions that are defined inside that module. So the dot operator kind of lets us drill in to our namespaces until we get to what we want, ultimately being a variable or a function. So we can also have packages that contain packages. Looking at this example, we're importing game. So game is a package that contains two other packages, sound and graphics. Each of those packages ultimately contain the modules. So we just continue like we did before. We use that dot operator to drill down to the function that we want to use from these modules. So game.sound.speech.talk would drill in this way until it got to the talk function that's defined inside speech.py. Alright, so that wraps it up for our lecture on modules. I'm going to create a second video that goes into an example of using modules in Python, so I'll talk to you guys in that one. Thank you.